Finally, we have the last part of this webinar that includes the Q&A session. For that, I will invite Engineer Ashish Sabkota to moderate the session. So over to you, Mr. Ashish.
Amal. And thank you, Dr. Naveed, for the enlightening presentation about the strut and tie modeling. So we have a couple of questions regarding the basic terms about the STM. So I would like to go first with those things. So there is a question from Sudeep, and he's asking that if we can apply the strut and tie method for the 3D structure, considering the width of the beam.
Pile cap is a good example of how the stresses will flow through a 3D structure. But if it's a beam, it's a deep beam, and the primarily the support is the load transfer is in plane, then there's no transfer on the transverse direction. That means let's say the width of the beam and the height of the beam, the ratio is less than 1/3. Then we probably need only a single layer of strut and tie model will be sufficient. But if the width is large, like a pile cap, then we may think about, and the column size is small, we may think about a three-dimensional transfer, like it showed in the pile cap.
Right. So moving forward, there is one question regarding the uniform distribution load. So what will be the strut and tie model for the uniform distributed load?
Yeah, that's a good question. Typically, we do not use strut and tie model for uniformly distributed. Although the mechanism that I showed you right from the beginning, where the beam is converted into a strut, into a truss, and we still have the same mechanism. The only difference is that the struts and ties are uniformly spaced, and there's no clear load path because there's no point load to transfer to link to the support. So we have a uniformly spaced struts and ties, which is typically how we design a shallow beam for reinforced concrete by using the vertical stirrups, which are acting as ties, and the concrete is assumed to be the struts in between. So that's still possible. So to answer that explicitly, yes. For a uniformly distributed load, we will have a uniformly distributed struts and ties.
So moving forward, so Im Sopana is asking, does this strut and tie method require the concept of plane section remains plane?
No, actually not. Exactly the opposite. So for the strut and tie is normally used where plane sections do not remain plane. And that's the whole point. It's a disturbed region where shear deformations are primarily the concern, and flexural deformations are not important. So actually it's the opposite. But right. for plane portion, we can have a uniformly distributed truss, as I showed you earlier in the beginning. Yeah.
So is there any code limitation about selecting the strut and tie method and the beam theory?
Yeah. So once again, like I said, if the region is B region, which means the region between D regions, you should or you can use the beam theory, traditional beam theory. When you're in the D region, the codes recommend to use strut and tie approach. So it's rather clear. D region, strut and tie, B region, code methods, the traditional beam methods. Although, strut and tie can be used across, but generally we don't do that.
There is one question about the nodes. I think we already discussed about the hydrostatic and non-hydrostatic, so I'm going to skip that. And there is the other thing about, so do we need to provide the compression steel while designing strut and tie method?
Yeah, generally it's not required because unless the compressive stress in the strut is really high, we normally do not need that. But that's why, like I mentioned, the struts have to be checked as a column. So if you find that the strut is not, the concrete in that strut is not sufficient, we need to put reinforcement in a column. So it's just like adding reinforcement as a column, either as confinement or as the longitudinal bars, which will become the compression bars. But it's very rare. Only maybe exists in very heavy loads and very narrow beams. But remember, most of these times, the loading will be governed by the transferring members, because they also have to be designed for the compression. So normally the column size itself is already designed for compression and bending and all. And the strut will not be smaller than the column size. So it's typically like that.
Can we apply the Strut and Tie method in the design of the arch bridge foundation, which is difficult in terms of design by general beam analogy?
Yeah, once again, as I mentioned here, we have to look at the load and support. The arch beam foundation, because it's mostly supported by soil. If it is supported by soil and there's only a point load, then point load coming from the arch, then it can still be done. But typically, if you have piles below that, then it's just a pile cap design. So it depends on how the foundation is designed. If it's a mass concrete and it is mostly sitting on soil and the arch is very large, then we can form a kind of a large strut and tie portion. But typically for footings which are supported by soil, the strut tie model doesn't work very well.
There is one fundamental questions that could you clarify again how we confidently say it is a lower bound method?
So, like I said, when we are the assumptions of these strut and tie models is that we are ignoring all tension in concrete, and which is not true. Tension and we are assuming that all sections, all portions of the member which is in tension is already cracked and gone, and that has zero capacity. But that's not true. First of all, most of the portion in the large members, they are even though they are in tension, they are still within the tensile capacity of the concrete. Secondly, we are removing all of the concrete between the strut and ties like a triangle, but actually that concrete still exists. That still has a capacity. So from that angle, already we are assuming a much lower portion of the structure contributing to the forces than the actual structure is present.
So there is one question regarding the the cracking modifier. So what should be the value of the cracking modifier for the members to be analyzed as STM?
Yeah, normally, like I said, there is no need for any cracking modifier because the compression is fully compression and we are using as a compression element, and tension is already all concrete all concrete with tension is already gone. So the concept of the cracking doesn't really apply in that sense, because we are going to calculate the tension in the members assuming that it's already absent. It's purely replaced by steel. So that's why we normally do not use any further cracking factors when we do the sizing of the initial members, although could be important in indeterminate structures. For determinate structures, it doesn't matter what sizing you use. If the truss is determinate, the stiffness is immaterial. But if the structure is indeterminate, yes, the initial stiffness or the sizing of the truss, the struts, will alter the results that you get. And we may have to do a couple of iterations on that.
Right. So maybe for today, I will take the last question. So it's about the STM for the deep wall fin. So do we still need to take care of the out of plane bending in that?
Yes, absolutely. So out of plane bending and buckling is a completely different problem. We are only talking about in-plane load transfer through strut and tie model. So buckling, out of plane buckling and out of plane bending should be designed as a normal problem that exists in a wall or a deep beam.
Okay, so I think that's all for now. And then maybe there are a couple of other questions based on the particular case. And also some of the questions we have already covered in the presentation. So we will try to cover them again. We will just take a look and then revise and then can share it with the participants. And I would also like to thank all the participants.
So thank you, Engineer Ashish, for moderating the Q&A session. Hopefully, most of the questions has been answered. Before closing, I would like to thank our presenter, Dr. Naveed Anwar, for sharing his expertise. And also, I would like to thank all of our attendees for joining us today. So regarding the webinar recording and the resources, we will share it in the follow-up email. For more information, you can visit our website, www.csibangkok.com. If you have any questions and further queries, please email us at learning@csibangkok.com. So we are going to close this webinar today. Have a great day.